It's funny how, like, the whole conversation around how we build software is, like, really changed.
Oh, yeah.
We used to sort of joke that software architecture was
Right.
just the stuff that's hard to change later, you know?
Yeah.
But, like, now, especially with microservices and all that
Right.
adaptability, it's not just, like, something you want. It's, like, the whole point, right?
It's fundamental now, yeah. You
Yeah.
have to think about how it's going to evolve from the beginning.
Yeah. And that kind of brings us to today's deep dive, the fundamentals of software architecture.
Okay.
We've got a really cool book here,
Right.
Fundamentals of Software Architecture, second edition by Mark Richards and Neal Ford from O'Reilly.
Oh, yeah. I've seen this one.
Yeah, and you, our listener, you flagged this one for us.
Okay.
You're really looking to get a solid understanding of modern software architecture
Right.
without getting like totally lost in the weeds, right?
Yes, absolutely.
So our mission today is to really like pull out that core knowledge that's going to be valuable
Okay.
right away.
That's a great goal.
So we're going to be looking at like what software architecture actually is, the critical parts that make it up, and why it even matters so much in today's world.
Definitely important stuff.
And then we're also going to get into a little bit of the soft skills too.
Oh, very important.
Yeah.
Yeah, at least half the job, you could say.
Yeah. So, okay, let's like unpack this a little bit.
Sure.
What exactly is software architecture like, according to Richards and Ford?
Wow.
It's not just one thing, is it?
Yeah, it's not a simple answer. It's pretty nuanced. There's a lot of interconnected parts to it all.
Okay.
Figure 1-1 in the book really shows, it shows how it's like this whole web of different things.
Okay.
You got the system structure itself, then you have the architecture characteristics, the ilities,
Right.
the logical components, the styles of architecture we choose, and then, most importantly, all the decisions we make along the way.
And those earlities, things like availability, scalability, security,
Yeah, those are the big ones.
they're not just like nice to haves, right?
No, not at all. They're mission critical. You can see that in figure 1, too.
Right.
They're at the heart of it all.
Yeah.
I mean, those architecture characteristics, that's what they're called.
Okay.
They define what the system can actually do and how good it is at doing it.
Right.
And that's how we measure if it's successful or not.
So it's not enough to just have all the features and functions you need.
Exactly.
If it crashes all the time or can't handle more users, it's just not going to work.
Exactly. You need those abilities to make sure the system actually delivers.
Yeah. And the authors, they really dig deep into these abilities.
Oh, yeah. They dedicate a big chunk of the book to them.
It shows how crucial they are.
Absolutely.
Okay, so then we've got the architecture decisions in figure 1-5.
Right.
It seems like these are basically the ground rules for building this system.
Yeah, you could say that. They're the guiding principles for how we're going to construct everything.
Okay.
So we're talking about things like what technology are we going to use? How are different parts going to communicate with each other? That sort of thing.
Right.
The book kind of introduces these decisions early on, but it really gets into the nitty-gritty of making and documenting those decisions later on.
Okay.
Because it's not a one-time thing.
Yeah.
You're making these decisions throughout the whole development process.
Gotcha. So it's more about the ongoing process of decision-making.
Exactly.
Okay, cool. So the book talks about these laws of software architecture.
Uh-huh.
It makes it sound really serious.
Well, yeah, they're trying to lay down some fundamental truths about the field,
All right, so what are these core truths, these laws?
So they came up with 3 main laws. The first law, and probably the most fundamental one, is that everything in software architecture is a trade-off.
Interesting. So it's like every decision you make has a consequence.
Yeah, basically.
Yeah.
You can't have it all. You're always going to be giving up something to gain something else.
Okay, let's dig into that a little bit more.
Sure.
I mean, it seems obvious on the surface, but I'm sure there's more to it than that.
Yeah, there definitely is. So they give 2 important corollaries to this first law.
Okay.
The first one is that if you think you've discovered something that isn't a trade-off, more likely you just haven't identified the trade-off yet.
Oh, that's interesting.
Yeah.
It's like there's always a hidden cost.
Yeah, it's like a reminder to always look deeper and think about all the possible angles.
Right.
That seems like a purely positive choice in one situation could have downsides in another. It's all about context.
Yeah, like choosing a database that's super fast.
Right.
Might be great for performance.
Exactly.
But then maybe it costs a ton of money or you'll lose some data consistency.
Exactly. You always have to weigh the pros and cons.
Okay. That makes sense.
Right.
And the second corollary says you can't just do trade-off analysis once and be done with it.
Right, because things change. The world is constantly evolving. New needs pop up. Technology advances. Business priorities shift.
Right.
So what was a good trade-off yesterday might not be so good today.
So you're saying we can't just like have one big meeting decide on all the architectural defaults and then just coast?
No, not really. The authors call that trying to have a one big trade-off jamboree, and they say it doesn't really work.
Okay, so like what's an example of this?
Well, they talk about trying to always default to using choreography in distributed workflows,
Okay,
is where services communicate through events without a central conductor.
right.
Now, that can be great for keeping things loosely coupled,
Yeah.
but it's not always the right approach.
Okay.
Sometimes you need orchestration where you have a central service that's kind of like a conductor managing the workflow,
Right.
especially for complex processes where you really need to keep things in a specific order.
So the best approach really depends on the situation and the trade-offs you're willing to make.
Exactly. There's no one-size-fits-all solution in software architecture.
Gotcha. All right, so the second law is why is more important than how.
Yes.
And I'm guessing this connects directly back to documenting those architectural decisions we talked about.
You got it. Understanding why we made a particular decision is super important in the long run.
Okay.
It's more valuable than just knowing what the decision was.
Right.
So we need to capture the context, the trade-offs we considered, the goals we were aiming for.
Okay.
And that's where architectural decision records or ADRs come in.
Right. Because they provide that history and the reasoning behind the decisions.
Exactly. And that prevents us from just blindly sticking to decisions that might not make sense anymore.
Yeah, it's all about having that context.
Exactly.
So then we have the third law, which is new in this edition of the book.
Uh-huh.
And it says that most architecture decisions aren't binary, but rather exist on a spectrum between extremes.
Right. It's not always black and white. There's often a lot of gray area in between.
Right.
Like take the whole monolithic versus microservices debate.
Mm-hmm.
It's not just an either or choice. There are options in between, like the modular monolith.
Right.
So recognizing this spectrum allows us to make more nuanced decisions.
Yeah, it's about finding the right balance for your specific needs.
Exactly.
Now, speaking of evolving and changing and stuff, I imagine it must be a real challenge for software architects to keep up with all the new trends and technologies.
Oh, it definitely is. It's a constant struggle to stay current.
Yeah.
The book actually addresses this in Chapter 2.
Okay.
It talks about different techniques and resources that architects can use to stay on top of things,
Right.
like continuous learning, actively seeking out new information, attending conferences, reading blogs and articles, that sort of thing.
Yeah, because the tech world moves so fast.
It really does. If you're not constantly learning, you're going to fall behind.
For sure. So once those architecture decisions are made, it's the architect's job to make sure everyone actually follows them.
Yeah, that's a big part of the role.
And that sounds like it could be tough.
It can be. It requires good communication and leadership skills.
Yeah, for sure. The book gives a great example of restricting database access in a layered architecture.
Oh, yeah, that's a classic one.
So like if you decided that the presentation layer shouldn't be talking directly to the database,
all right.
but then some developer decides to do it anyway.
Well, then you've got a problem.
Yeah, because it totally undermines the reasons behind that decision.
Exactly. Which was probably to prevent UI changes from directly impacting the data structure.
Right.
So the architect needs to be vigilant and make sure the team is adhering to the principles.
Yeah, and Chapter 6 talks about using fitness functions to kind of automate this governance.
Yeah, fitness functions are like automated tests for your architecture.
Oh, that's interesting.
So you can actually write code that checks for things like unauthorized database access.
Okay, so you're not just relying on people to follow the rules.
Right. You're building automated safeguards into the system.
Gotcha. It's cool that the book also talks about the importance of the human element,
Oh, yeah, for sure.
like leadership and soft skills.
At least half of being a good architect is about people skills.
Really?
Yeah, they actually quote Gerald Weinberg in the book.
Yeah.
He famously said, no matter what they tell you, it's always a people problem.
Uh-huh. That's so true.
It's a good reminder that even in a technical field like software architecture, you're always dealing with people.
Yeah, for sure. So architects, they're not just technical experts, they're also leaders.
Exactly. They need to be able to guide their teams, build consensus, resolve conflicts, all that stuff.
Yeah, and part 3 of the book is dedicated to these soft skills.
It shows you how important they are.
Absolutely.
Yeah.
So
Yeah.
when you move into an architecture role, the kind of knowledge you need changes, right?
Definitely. It's not just about knowing how to code anymore.
Right.
Figure 2.3 in the book actually illustrates this change in the nature of knowledge.
Okay, so what does it say?
Well, as you move from being a developer to an architect,
Mm-hmm.
the focus shifts from having deep technical expertise in a few specific areas
Okay.
to having a broader understanding of a wider range of technologies.
So it's more about breadth than depth.
Exactly. Figure 2.4 really contrasts this. It shows the difference between technical depth, which is like how much you know about one specific thing, and technical breadth, which is how many different things you know about.
Right.
And for an architect, that breadth is super important.
So it's better to have a good understanding of like 5 different solutions to a problem
Yeah.
than to be like the world's leading expert in just one.
Exactly. Because as an architect, you need to be able to make decisions
Mm-hmm.
that align technical capabilities with all sorts of different constraints.
Right.
And to do that, you need to have a broad understanding of what's out there.
Gotcha. And figure 2.5 suggests that you might even have to sacrifice some of that deep expertise
Yeah.
to gain a broader portfolio of knowledge.
It's like you're trading off depth for breadth.
Right.
But that's what's needed to be a good architect.
Okay, so it's all about adapting your skill set to the new role.
Exactly.
The book also talks about some common pitfalls that architects should avoid.
Oh, yeah. There are definitely some traps to watch out for.
Like what?
Well, one of them is called the frozen caveman anti-pattern.
Haha, what?
Yeah, it's a funny name.
Yeah, what's that all about?
So it describes these architects who get fixated on a particular irrational concern,
Ugh.
often based on some bad experience they had way back in the past.
Right.
And they bring it up in every single architectural discussion,
Uh-huh.
no matter how irrelevant it is to the current project.
Oh, wow, so they're stuck in the past.
Exactly. They're like a caveman who's been frozen in time.
I get it.
The book actually tells this funny anecdote about these client architects who were obsessed with the possibility of losing communication with Italy. Yeah, apparently they had some minor incident years ago,
Okay.
and it just like totally traumatized them.
Ah.
So every time they talked about architecture, they'd be like, but what if we lose Italy?
Oh, my God.
Even though it had nothing to do with the current project.
That's hilarious.
It is, but it also shows how important it is to stay grounded in the present.
Yeah, don't let those past anxieties cloud your judgment.
Exactly.
Okay, so how do we combat this frozen caveman syndrome?
Well, one way is to just make sure you're constantly learning and broadening your knowledge. And
Right.
the book actually gives this simple but effective tip called the 20-minute rule for learning.
Okay, tell me more about that.
So the idea is to carve out just 20 minutes every day for dedicated learning.
Yep.
And they emphasize that it shouldn't be during lunch or after work,
Right.
because you're more likely to get interrupted or be too tired.
Right.
So find a time during the day when you can really focus and make it a habit.
So like blocking off 20 minutes on your calendar every day.
Exactly. Make it a non-negotiable part of your schedule.
And figure 2.6 shows us visually.
Yeah, it's a good reminder to make time for learning.
Oh, wait. And for keeping up with all those trends and stuff.
Yeah.
The book mentions this tool called the ThoughtWorks Technology Radar.
Oh, yeah. That's a great resource.
Figure 2.7 shows it.
It basically categorizes different technologies into 4 rings.
Okay.
There's hold, which are things you should be cautious about.
Okay.
Assess, which are things that are worth exploring.
Hmm.
Trial, which are things you can experiment with on real projects.
Okay.
And adopt, which are things that are ready for widespread use.
So it kind of gives you a sense of what's hot and what's not in the tech world.
Exactly. It's a good way to stay informed about the latest trends.
So we started this whole thing talking about how everything in architecture is a trade-off.
Right.
And Neal Ford has this great quote in the book.
Yeah.
He says, "There are no right or wrong answers in architecture, only trade-offs."
I like that. It really sums it up.
And the book uses this practical example of an item auction system
Uh-huh.
to show how this plays out in a real-world scenario.
Okay, tell me more about it.
So figure 2.8 shows this system.
Okay.
And there's this bid producer service
Mm-hmm.
that needs to communicate bid information to other services.
Okay.
And the architect has to decide how to do that asynchronously.
Right.
And they have 2 options, either using queues,
Mm-hmm.
which is like a point-to-point approach,
Right.
one message, one recipient,
Ex-
or topics, which is like
Yeah.
a publish and subscribe model.
Okay.
One message, multiple recipients.
Right.
And the book shows these visually in Figure 2.9 and Figure 2.10.
So what are the trade-offs?
Well, topics seem like they're better for architectural extensibility
How so?
because new services can just subscribe to the topic
Mm-hmm.
without the producer needing to know about them.
Okay.
So with topics, the bid producer only needs one connection.
Right.
But with queues, it needs a separate connection for each consumer.
Okay.
And if you add a new consumer, you have to actually go and modify the bid producer to connect to a new queue.
So topics are more decoupled and flexible.
Exactly.
But there must be some downsides to using topics, right?
Yeah, there are, and Table 2.1 lists them out.
Okay.
So one of the big ones is data access and security. Because with a topic, everyone who subscribes gets all the data.
All right.
So if there's sensitive information that some services shouldn't see, that's a problem.
Yeah, that makes sense.
With queues, you have more control over who gets what. There are also differences in things like monitoring scalability and how well they handle different types of contracts.
So like you said before, there's no one right answer.
Exactly.
It all depends on the context and the trade-offs you're willing to make.
Right, and the book really drives this point home.
Yeah.
It says that choosing between queues and topics is a conscious decision about which doors you're choosing to close.
I like that analogy. It really captures the essence of architectural trade-offs.
Yeah, and it's not just about designing the system initially, right?
No.
Architects also need to, keep their own technical skills sharp.
Oh, for sure.
They can't just become these ivory tower architects who are detached from the code.
Right. You gotta stay hands-on.
Yeah, and the book actually has some advice on how to do this.
Like what?
Well, one suggestion is to use automation.
Okay.
So like creating simple tools and analyzers that can help the development team
Right.
with repetitive tasks.
That makes sense.
This way, the architect gets to keep their coding skills sharp,
Mm-hmm.
and the team becomes more efficient.
Mm-hmm. It's a win-win.
Exactly. Okay, so moving on to Chapter 3, which is all about modularity.
All right.
And it starts with this quote from Glenford J. Myers from way back in 1978.
Wow, that's a while ago.
Yeah, and it's still relevant today.
What does he say?
So he says that everyone talks about the benefits of modularity, but nobody really knows how to achieve it.
Uh-huh. Yeah, that sounds about right.
It's like this enduring challenge in software architecture.
For sure. We all know that breaking down systems into smaller, manageable pieces is a good thing.
Right.
But actually doing it well, it's not so easy.
Yeah, and the book points out that there's not even a clear definition of what modularity is.
Really?
Yeah, you can find all sorts of different definitions online, and they often contradict each other.
That's not helpful.
No, it's not.
Mm-hmm.
So the authors actually provide their own definition of modularity in the book,
Okay.
just so they can be consistent.
That makes sense.
And they also make this point that preserving good modularity is an implicit architecture characteristic.
Okay, what does that mean?
So it means that it's not usually a direct requirement that someone will write down,
Right.
but it's something that's essential for a well-designed system.
Okay, I see.
Like you wouldn't have a requirement that says the system shall have good modularity.
Right.
But if it doesn't have good modularity, it's going to be a nightmare to maintain.
Yeah, I could see that.
So it's one of those things that you have to keep in mind, even though it's not explicitly stated.
Gotcha.
The book also distinguishes between modularity and granularity.
Yeah, those terms are often used interchangeably.
They are, but they're actually different.
Okay, so what's the difference?
So modularity is about breaking down a system into smaller independent pieces,
Okay.
like modules.
Right.
But granularity refers to the size and scope of those individual modules.
Ah, okay. I get it.
So you can have a modular system where the modules are still quite large,
Right.
or you can have one where the modules are very small.
So it's like the level of detail.
Exactly.
Modularity is about the structure, granularity is about the size. Okay, that makes sense.
And then we get into cohesion and coupling.
Which are like the two tillers of good modularity.
Exactly.
Yeah.
And they even quote Larry Constantine in the book.
Oh, really? What does he say?
He says, attempting to divide a cohesive module would only result in increased coupling and decreased readability.
So basically, if a module is already doing one thing well, don't try to split it up.
Exactly.
Because it'll just make things more complicated.
Right, and less readable.
Yeah, that makes sense.
And then they list out these different levels of cohesion.
Oh, really?
So there's functional cohesion, which is the best,
Okay.
where everything in the module is essential and related.
Right.
And then it goes down from there
It what?
to sequential cohesion, communicational cohesion,
Yeah.
procedural cohesion, temporal cohesion, logical cohesion.
Wow, there are a lot of them.
Yeah, and then at the very bottom, there's coincidental cohesion.
Which is the worst.
Yeah, where things are just grouped together randomly.
So the goal is to aim for that functional cohesion.
Exactly.
Keep related things together.
And that makes your code easier to understand and maintain.
Exactly.
Okay, so what about coupling?
Well, coupling is about the dependencies between modules.
Okay.
And the book mentions using graph theory to analyze this.
Oh, that's interesting.
Yeah, because when you think about it,
Mm-hmm.
all those method calls and returns, they form a kind of graph.
Right.
So you can use math to figure out how coupled your code is.
That's pretty cool.
And they talk about these concepts of afferent coupling and efferent coupling.
Okay, I'm not familiar with those.
So afferent coupling is like the number of incoming connections to a module.
Okay.
And efferent coupling is the number of outgoing connections.
So it's like how much a module depends on others versus how much others depend on it?
Exactly.
Okay, I see.
And there are actually tools that can analyze these metrics for you.
Really?
Yeah, so you can visualize how coupled your code is.
That's really helpful.
And then there's this other concept called connasance.
Okay, what's that all about? So connasance is like a more precise way of describing coupling,
Okay.
and it distinguishes between static connasance,
Mm-hmm.
which you can determine by just looking at the code,
Okay.
and dynamic connasance.
Which you can only figure out at runtime.
Right.
So what are some examples of static connasance?
So there's connasance of value,
Okay.
like when you have hard-coded numbers in your code,
Right.
and there's connasance of position.
What's that?
That's when the order of parameters in a method call matters.
Ah, okay. I see.
And the book says that static connasance is generally better
Why is that?
because it's easier to analyze and fix.
With tools.
Exactly.
Yeah, makes sense.
And then there's this idea of the locality of connasance.
Okay, what's that?
So it basically says that coupling within the same module is less of a problem
Okay.
than coupling between distant modules.
So like if two classes in the same module are tightly coupled,
Mm.
it's not as big of a deal.
Exactly, because they're already close together in the code.
Right. It's more about managing dependencies between larger units of code.
Exactly.
Okay.
So moving on to chapter 4, which is all about architectural characteristics.
Right.
We talked about the ilities before.
Yeah.
But this chapter really defines them in a more formal way.
Okay.
And it starts by talking about structural design.
Which is one of the core responsibilities of a software architect.
Exactly.
Huh.
And structural design involves two key activities.
Okay.
One is analyzing architectural characteristics.
Which is what this chapter is all about,
Right. And the other is designing logical components.
which we'll get to later.
Exactly. And figure 4.1 shows how these two activities fit into the bigger picture
Okay.
of creating a complete software solution.
Right.
It also emphasizes the difference between the architect's role
Mm-hmm.
and the tasks of coding and detail design.
Okay, so what's the difference?
Well, the architect is responsible for defining, discovering, and analyzing these architectural characteristics.
Right.
But they're not the ones who are actually writing the code or doing the detailed design.
So they're more focused on the big picture,
Exactly.
the why and the how,
Right.
rather than the what.
Exactly.
Okay.
That makes sense.
And I noticed that they prefer the term architectural characteristics over non-functional requirements.
All right. They talk about that in the book.
Why do you think that is?
Well, I think it's because non-functional requirements kind of downplays the importance of these things.
Right.
Like it makes it sound like they're secondary to the functional requirements.
Right.
But in reality, these characteristics are often just as important.
Yeah, if not more so.
Exactly. Like if your system is super secure,
Mm-hmm.
but it's always crashing,
Right.
it's not going to be very useful.
Exactly. So architectural characteristics puts the emphasis where it belongs.
On the things that really matter for the success of the system.
Right.
Okay, I get it.
And they also make this distinction between design requirements,
Mm-hmm.
which is what the application should do,
And architectural characteristics.
which is more about how to implement it and why we're making certain choices.
Exactly. So it's like the difference between what and how.
Right.
So a design requirement might be something like process a payment.
Okay.
But then an architectural characteristic would be more like
Mm-hmm.
the payment processing must complete within 200 milliseconds.
Okay.
Or the payment processing must be protected against unauthorized access.
So the design requirement is the what, and the architectural characteristic is the how well or the why.
Exactly.
Okay, that's clear.
And these characteristics can be either explicit,
Mm-hmm.
meaning they're clearly stated,
Right.
or implicit.
Meaning they're kind of implied.
Exactly. So like specific uptime percentages are usually explicit
Okay.
because they're often part of service level agreements.
Right.
But things like maintainability or avoiding technical debt,
Mm-hmm.
those are usually implicit.
Because they're harder to quantify.
Exactly. But they're still super important.
Yes.
And the book also points out that certain operational characteristics,
Like what?
like being able to handle a lot of traffic,
Right.
often require specific structural support in the architecture.
Okay, so you need to design for them from the beginning.
Exactly.
That makes sense.
Now, the book really stresses the importance of choosing the fewest critical architectural characteristics.
Why is that?
Well, because each characteristic you add,
Mm-hmm.
it adds complexity to the system.
Right.
And if you try to support everything,
Yeah.
you end up with a solution that's way too complicated.
And probably doesn't do anything particularly well.
Exactly.
Okay, I see.
So the goal is to identify the characteristics that are absolutely essential for the success of the application
Right.
and then focus on those.
And make conscious trade-offs where necessary.
Exactly. And they even have this phrase that I like.
What is it?
They say you should aim for the least worst architecture.
Uh-huh. I like that.
It's like accepting the fact that you can't have it all
Right.
and then making the best choices you can with the constraints you have.
It's about finding the best compromise.
Exactly.
Okay, cool.
So then they go on to define a whole bunch of different architectural characteristics,
Oh, yeah, there's a whole list of them.
both operational ones.
Like availability, performance, recoverability.
Exactly. And cross-cutting ones.
Like security, maintainability, scalability.
Right. And they acknowledge that any list like this is probably incomplete
Yeah.
and that some of the terms can be kind of ambiguous.
Right, because there are different definitions floating around out there.
Exactly.
So what are some examples of ambiguous terms?
Well, like interoperability versus compatibility.
Yeah, those can get tricky,
And even learnability can mean different things to different people.
depending on the context.
Exactly.
Okay, I see.
And one interesting point they make is that functional appropriateness,
Mm-hmm.
like whether the functions actually do what they're supposed to do,